Now that you've learned about extreme value points, you can learn about points of inflections, which I will be calling PI. A point of inflection is the second derivative of the original function. Our original function was f of x equals 3x to the fourth minus 8x cubed. In our EVP problem, we found the first derivative, which we found to be f prime x is 12x cubed minus 24x squared. And we found that the EVP was at the point 2, negative 16. So now we have to find the point of inflection. To find the point of inflection, you have to take the second derivative. So the first derivative, 12x cubed minus 24x squared. Now, using the product rule, we will take the second derivative. So 3 times 12 is 36. Subtract 1 from the cubed to get squared. 2 times 24 is 48. Subtract 1 from the 2. Our second derivative is 36x squared minus 48. What this PI will show you is where the graph changes shape. So I will use the symbols concaves up or concaves down. Now that we have the second derivative, we have to set it equal to 0. When we do that, we get 36x squared minus 48x equals 0. When we do this, we see there's a common factor that we can pull out. This common factor is 12x. When we pull that out, we're left with 3x minus 4 equals 0. So now we have to set each one equal to 0. So 12x equals 0, you get x equals 0, and 3x minus 4 equals 0. So you need to add 4 to both sides. So 3x equals 4, and then you divide the 3 from both sides to get x equals 4/3. So our x are x equals 0 and x equals 4/3. Now that we found the x's, we can set up our derivative sign chart. We'll put the x on top and the second derivative on the bottom. Using our x's, we set up x less than 0, x equals 0, 0 less than x less than 4/3, x equals 4/3, and x greater than 4/3. To find out if the second derivative is positive or negative, we will plug in numbers within the range we found into the function. So we'll plug in a number less than 0, which I used -1. So 36 -1 squared minus 48 -1. When we do that, we find that it equals 84. So it's positive. So here we find positive. So here it equals 0. Here it also equals 0. Then we have to plug in a number from this range of numbers. I used 1. 36 times 1 squared minus 48 times 1 equals -12. So that's negative. So we put negative. Then we have to plug in a number that's greater than 4/3. I used 2. So we set up that equation. 36 2 squared minus 48 times 2. When you plug in those numbers, you get that it equals 48. So it's positive second derivative. So we'll put a positive here. Now that we have our derivative sign chart, we can find where the graph changes shape. Since it changes from positive to negative here, we find that the concavity is up. Since it changes from negative to positive here, we find the concavity is down. If there is no sign change, there would be no change in shape in the graph. Thus, there would be no point of inflection. Now that we know where the graph is changing shape, we know that there's definitely a point of inflection there. So we can plug our x's into the original function. So f of 0 and f of 4/3. So we get 3 times 0 to the 4th minus 8 times 0 cubed. So when you get 0 minus 0, you're left with 0. Now we have 3 times 4/3 to the 4th minus 8 times 4/3 to the 3rd. When you plug those numbers into the calculator, you're left with negative 9.481. So our PIs are at 0, 0, and 4/3, negative 9.481. Now we need to graph our original function. When we graph it, it looks a little something like this. This is just a sketch, so it's not accurate. Now we need to graph our points. We have our PIs at 0, 0, and 4/3, negative 9.481. Then we graph our EVP, which is at 2, negative 16. And that's the graph and the points we found.